In this video, we will look at multiplying a decimal by another decimal using an area model. The work that is shown in this video should come after students have had experience solving problems like this using base 10 pieces to create the array and making connections to an area model. Remember, the focus of this standard is to use models, drawings, and strategies based on place value to compute problems. Let's take a look at how we can solve 2 and 7 tenths times 4 and 3 tenths using an area model. We would want to begin by estimating so that when we have our final answer, we can determine its reasonableness. So the first thing we would look at here is 2 and 7 tenths, and we know that 2 and 7 tenths is close to 3 wholes. That would be a friendly number for estimating. I know it's just 3 tenths away from 3 wholes. And then 4 and 3 tenths is close to 4. It's only 3 tenths more than that. So I could say for our estimate 3 times 4, which is 12. So this lets me know that our actual answer should be somewhere around 12. The next thing we'll want to do is draw a rectangle for our area model. And while we are going to use the area model very similarly to what we did when we worked with whole numbers and an area model, we are going to set it up just a little bit differently. One thing that will be the same is we will still decompose both factors. So we will decompose these numbers into their wholes and their tenths. So I'm going to put here 4 plus 3 tenths. And then here's where I'm going to show 2 plus 7 tenths. Now, for us to really be able to represent the 3 tenths and the 7 tenths, we're going to want to split our model into the wholes and the tenths, just like we did with the base 10 pieces. And so what I mean by that is here, I'm going to create a section where I can show 3 tenths of a whole. And then for the rest of this here, I'm going to set it up for the 4 wholes. So in other words, what I've done here is here's where I can show the 4 wholes. And then in this section, in this hole here, is where I will show the 3 tenths. And we're going to similarly set up for the 2 and 7 tenths. So I'm going to create a section here. I will use this hole down here to show the 7 tenths. And then here I can split for the 2 wholes. So I'll be able to, currently this looks like an array that is a 5 by 3. But what I will be able to do, is create a 4 and 3 tenths by 2 and 7 tenths array. So I'm actually going to just switch screens where I have an array set up already that is a 5 by 3 that I can use to solve this problem. So like we showed, we would want to decompose. So we have the 4 and 3 tenths by the 2 and 7 tenths. And now, just for making partitioning the last hole into the tenths, I've just switched to this model. So I would want to split up this hole that's to represent the 3 tenths into 10 equal parts. So there I'll be able to represent just 3 tenths rather than taking that entire whole. And then I'll do the same thing in the section that I'm going to use to represent the 7 tenths. So now that I have those last 2 wholes split up into tenths, I can go ahead and mark off the part that we are actually working with here. So our actual area model is a 4 and 3 tenths. I'm just going to come over here and capture 3 of the tenths. 1, 2, 3. So we actually have a 4 and 3 tenths by 2 and 7 tenths. So we'll come down here and make sure we capture 7 tenths. 1, 2, 3, 4, 5, 6, 7. Now I'm going to box in this section. Because again, if I looked at this entire model, that would be looking at a 5 by 3 array. But the numbers we are multiplying here are just 4 and 3 tenths by 2 and 7 tenths. So I have now created a section that's just 4 and 3 tenths by 2 and 7 tenths. And we can just work to figure out the value of each section. So if we look here first, I can look and see how many wholes we have in the section that is 4 by 2. And I can know that we have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 wholes. So this is where we had 2 times 4. And we have 8 wholes. Next, we can come and look over here to the side where we did 3 tenths 2 times. So I have 3 tenths right here. And then I have another group of 3/10 right here. And when I have 3/10 two times, that gives me a total of 6/10. I'm just going to record this out to the side since there's not room there. So again, here I had 3/10 times 2, and that gives me 6/10. Now we'll come down below here where we did the 7/10 times 4. So here's one group of 7/10. And we know we have that 4 times because we have that here and here. That would be twice. Here we have it a third time. And then here we have it a fourth time. So 7/10 times 4. And so here I can record in, this is where I have 7/10 times 4. And we could count all of these tenths. We can use our number sense to help us, but here we have 28 tenths altogether. And we know that would make 2 wholes and 8 tenths. So we have 2 and 8 tenths there. And then this is exactly like what we saw when we used a base 10 pieces to create the array to multiply 2 decimal numbers. What we have over here, where we multiplied 3/10 by 7/10, we have hundredths. We've done a lot of work to figure out that when we multiply tenths times tenths, our product is some number of hundredths. So here I'll just need to figure out, well, exactly how many hundredths do we have right down here for where we multiplied 3/10 by 7/10. So we could count those. We have 3, 6, 9, 12, 15, 18, 21. So we have 21 hundredths right there. So I'll record out to the side here, 3/10 times 7/10. And that gave us 21 hundredths. Now what we'll need to do is add our partial products together, and we will have our final answer. So we'll start, I know here if I combined the 8 wholes and the 6/10, that would be 8 and 6/10. And now if I add to that 2 and 8/10, let's see how we could do that. Well, we would know that 8 plus 2 would give us 10. And then we know 6/10 plus 8/10 would give us 14/10, which is 1 and 4/10. So now I know that together, that 10 plus the 1 and 4/10 would be 11 and 4/10. And now I just need to add our last partial product, which was 21 hundredths. So 11 and 4/10 plus 21 hundredths. I know I can think about that 4/10 as 40 hundredths. 40 hundredths plus 21 more hundredths would be 61 hundredths. And so that lets me know here that we have 11 and 61 hundredths. So this would show us that the product of 2 and 7/10 and 4 and 3/10 is 11 and 61 hundredths. Remember, we want to compare that to our estimated answer to help check the reasonableness. We estimated that the answer would be around 12, and we can see that 11 and 61 hundredths is just 39 hundredths away from 12, so that is very reasonable. So again, this is how you can use an area model to multiply 2 decimal numbers.